One common pre-processing habit can make your score look better than it should. We'll show the mistake and the clean fix you can reuse everywhere. You have a dataset. You scale features, and you want a fair model score. The pain is subtle. You do the right math, but in the wrong order, and you end up convincing yourself your model is better than it is. By the end, you will know exactly why scaling before splitting leaks information, and how to structure a simple scikit-learn workflow that avoids that trap. I'm Professor Pi, teaching AI foundations with simple Python. We are thinking about a typical supervised learning flow. You collect features. You standardize them to a common scale. You fit a model, and you report accuracy. That pipeline feels natural, and many tutorials show scaling early. The problem is not scaling itself. The problem is doing it across your entire dataset before splitting into training and test. That allows test data to influence the training transformation and inflates performance. At a high level, leakage means information from the test set leaks into the training process. Success here looks like a realistic estimate of how the model will behave on new data. For this video, we will build a small KNeighborsNeighbors baseline, then show the leaked version, then fix it with a pipeline and proper cross-validation, and finally tune the model safely. You will see how a single-line reordering fixes a big evaluation problem, and why scikit-learn pipeline keeps the scaler honest. Next, we'll build the baseline and get a reference accuracy to compare against. This snippet builds a scikit-learn KNN baseline to set a reference accuracy. This snippet loads a small example dataset, splits it into training and test, creates a KNeighborsClassifier, fits the classifier on the training features and labels, and then predicts on the held-out test set to print an accuracy. The main idea is to show a simple reference number before any scaling or fancy tuning. Key lines create the train test split, instantiate the KNeighborsClassifier, call fit on the training split, and call score or accuracy on the test split. This baseline gives a clean point of comparison, so you can see the effect of later mistakes or fixes. Now, we'll show the common but wrong approach that leaks information. This snippet demonstrates leakage by fitting scikit-learn StandardScaler on all data. This example takes the full feature matrix and calls StandardScaler to remove the mean and scale to unit variance, and it performs that fit before splitting into training and test. After scaling the entire dataset, the code then trains the KNeighborsClassifier on the scaled training portion and evaluates on the scaled test portion. Because the scaler saw the test data during its fit step, the scaling parameters include information from the test split, which can subtly shift distributions and lead to an optimistic accuracy. The lesson is that fitting the scaler on all data confounds evaluation. Next, we'll apply a scikit-learn pipeline so transformations happen inside training. This code fixes leakage using a scikit-learn pipeline to fit scaling on training only. This code shows how to wrap StandardScaler and the KNeighborsClassifier into a single pipeline object so that when you call fit on the pipeline with the training data, the scaler is fit only on that training data, and then the classifier is trained on the scaled training features. The pipeline then applies the exact same scaling learned from training when you call predict on test data. Key lines build the pipeline steps. Call fit on the pipeline with training features and labels, and then call score on the pipeline with test data. Using a pipeline keeps transformation and model training in the right order and prevents accidental leakage. Next, we'll get a more reliable performance estimate with cross-validation over the pipeline. This snippet gets a more stable estimate via scikit-learn cross-val score on the pipeline. This snippet calls cross-val score, which runs repeated train test splits and returns an array of scores. while using the pipeline, so each fold fits its own scaler on the fold's training data. The core idea is that cross-val score simulates multiple independent holdouts and shows variance across folds, which gives a more robust view of expected performance than a single split. Important lines configure cross-val score with the pipeline and a scoring metric. Collect the score array and check the mean and spread. This reveals whether earlier accuracy was fragile or genuinely reliable. Now we'll tune neighbors and related knobs safely using GridSearch. This snippet tunes KNN via scikit-learn GridSearchCV and reports the final test accuracy. This code wraps the pipeline into GridSearchCV, which searches over a parameter grid such as different neighbor counts or distance weightings, and uses internal cross-validation so each trial fits scalars on training folds only. The main lines set up the parameter grid linked to the classifier step inside the pipeline. Call GridSearchCV with refit turned on, so the best parameters retrain on the combined training folds, and then evaluate the selected best estimator on a held-out test set for a final accuracy. Tuning inside the pipeline ensures that scaling never leaks during hyperparameter selection. In a real project, you would map this toy flow to your full dataset and keep the pipeline wherever data enters the system. The pipeline becomes the single object that gets serialized and deployed, so transformation and model stay in sync. Recap: preprocessing leakage happens when a transform is fit on data that should be unseen. Use a pipeline to ensure transforms are fit on training only. Caveat: pipelines stop this class of leakage, but you still need careful validation design for temporal or grouped data. Next step: scale this exact approach to a larger dataset and measure wall time and accuracy by adding Talming and stratified cross-validation, so you can trade speed for reliable performance. If AI Foundations in Python help, subscribe and watch the AI Foundations videos.